So it is said that brute force gets you an interview, but hashing gets you the offer. So welcome everyone to Techmine Guru. My name is Supratim and I'm your coach here at Techmine Guru. Today we are diving into lecture 23, focusing on interview problems on hashing. We are going to transition your thinking from brute force to O of n magic. So what is the agenda for today? So today we are cracking 4 critical patterns. Problem 1, longest substring. Problem 2, first non-repeating element, where we will discuss very common trap. Problem 3, zero-sum subarrays, and problem 4, subarray-sum equals k. So let's start with problem 1, longest substring. The problem asks us, given a string s, and you have to find the length of the longest substring without repeating characters. So if you see this example, ABC, ABC, BB, so what is the longest substring without repeating character is ABC, right? Similarly, this ABC also is one such substring which is without repeating characters. So what is the length of this substring? 3, right? What is the length of this substring? 3. Similarly, in this example, where all the elements are B, the answer will be 1. So this is the LeetCode problem. The link I have mentioned in the description. Now let's understand the solution behind the same. So here we will use a sliding window approach combined with a hash set. So here we will expand the window, that is the end pointer, until a duplicate element is found, and we will shrink the window, that is the start pointer, until the duplicate is removed from the hash set. And throughout this process, we will store all our active characters in a hash set. So let's see the code, and then we will dry run for this example. So as I told that we will have 2 pointers, one end pointer and one start pointer. So we will run a loop from end is equal to 0 to the length of the array or length of the string. Here in this while loop, we will check whether that element pointed by the end pointer is available in the hash set or not. If it is available, we will remove the element present in the start pointer, and we will keep doing it till our element present pointed by the end pointer is gone from the hash set. And finally, when we will come out of this while loop, we will simply insert the element pointed by the end pointer in the hash set, because our third point says that we have to store active characters in that hash set. And finally, when we have our end and start pointer, we will calculate the maximum length of the substring. So let's see this code is working as expected with the dry run from this example. So suppose this is our start pointer S, and this is our end pointer E. Now, since we are running a loop from end is equal to 0 to s dot length minus 1, that is string length, which is 7, right? So it will run till 7 minus 1, which is equal to 6. So our end pointer will run from the index 0 to index 6, right? So when the end pointer is at index 0, we will check whether it is present in the hash set or not. So right now we have an empty hash set. So it will check that the end pointer element is not present in the hash set. So this while loop will not work for this, and we will simply insert that element present in the end pointer into the hash set. So we have kept A inside that. Now after that, we will check the length of the substring. So what will be the length? Since initially answer will be 0 and end is at 0 and start is also at 0. So we have already learned in our previous classes that how to calculate the length of a substring. It is between start to end. It will be end minus start plus 1, right? So this is how we are calculating the length of the substring. Now the answer will hold 1, right? Now again in this for loop, the end pointer will increase. It will reach from 0 to 1, right? It will again check in the hash set whether it is present or not. It will see it is not present. So this while loop will not work. Now we will again insert the element in the hash set. So we kept B here. Now again answer will be checked. Now the end pointer will be at 1, right? Start pointer will be in the same place, which will be 0 and plus 1. So now our answer will contain 2 length, right? Similarly, the end pointer will move to C, right? Now we will again check whether C is present in the hash set or not. Again, this while loop will not work. Again, it will insert the element in the hash set, and since end pointer is right now is in 2 position, again we will calculate the max between our previous answer and the current answer, which will be 2 minus 0 plus 1, which will be now 3, right? Now again our end pointer will move to this part. It will check whether this element pointed by the end pointer is present in the hash set or not. It will say it is present. So our element pointed by the start pointer will remove one element from the hash set. So it will remove A from the hash set, and our start pointer will now point to here. Now we will again check in the while loop whether the element pointed by the end pointer is available or not in the hash set. We will see the element is now not present, right? So we will come out of this for loop and we will come to in this line. So here we will insert again element pointed by the end pointer into the hash set. So we inserted A again. Now we will calculate the length. So end pointer is pointing at 3, but this time start pointer will not point to 0 anymore because it will also move. So our start pointer will move to first position, and again we will get the result as 3 only. So this answer will be 3 only. Now again, in the next iteration, our end pointer will move to C. It will check in the hash set whether it is present or not. It will see that the element is present in the hash set. So it will remove the element pointed by the start pointer from the array. So where is the start pointer pointing? At B, right? So it will remove B from the hash set. Now again, it will check inside the while loop whether the element is present in the hash set or not, right? Because we need to keep shrinking the window. So still it will see C is still present. So now our start pointer will point this place. End pointer will see the element is still present in the hash set. So it will remove the element pointed by the start pointer. So it will remove C from the hash set now. And again, the start pointer will come here. But when start pointer will come here, when the while loop will check whether the element pointed by the end pointer is still present in the hash set or not, it will get false and we will come out of the while loop. And we know that we have to store the active character in the hash set while proceeding. So we will keep again this C back into our hash set, right? Now again, our end pointer will move to this B. It will check whether in the hash set our element pointed by the end pointer is present or not. It will see that in the hash set it is not present. So this while loop will not work for this end pointer. And when we will come to this line, it will again insert B into the hash set, right? At this time, our end pointer will be pointing at 5. Our start pointer is pointing at 3. So what will be the length? 5 minus 3 plus 1. It will be again 3 only. Now again, the end pointer will move towards the last element, which is 6. So it will see Z is present in the hash set or not. Again, this while loop will not work. It will come to this line and it will insert the element pointed by the end pointer in the hash set. And at last, this time, N will be at 6th position and the start is still at 3rd position. So it will be the new answer. It will be max of 3, 4. It will be 4 now, right? So the answer is 4. So what is the time complexity? So the time complexity is O of N only. Although we are running into 2 for loops, but still this will give O of N only, because for the same elements, 2 pointers are moving. So we have already learned this from our previous classes, that if elements are same where start and end pointers are moving on them, then that time also our time complexity doesn't get multiplied. So our time complexity will be O of N. Since we are taking hash set for this question, so our space complexity will be O of N. So this is our time complexity and this is our space complexity. So now let's move to the next problem of our day today, which is to find first non-repeating element. So you have been given n elements and you have to find first element that does not repeat. So for example 1, you have been given n is equal to 6 and in the array 1, 2, 3, 1, 2, 5 is there. And you have to tell which is the first element which doesn't repeat. So if you see 1 is repeating 2 times, right? 2 is repeating 2 times, right? But 3 and 5 are not repeating, right? But the answer will be 3. Why? Because 3 is the first non-repeating element. Similarly, if you see for this example, 4 is repeating 2 times, 3 is repeating 2 times, right? And 5 is repeating 2 times. 2 and 6 are the only element which is not repeating. But since 2 is the first non-repeating element, so it will be our answer. So let's see how we can solve this. So the idea is pretty simple, that we have to insert frequencies into HashMap and then we will iterate over the HashMap and it will tell us whether that element is present one time or not by seeing the value of the HashMap, which will tell us the frequency of that element. But this will fail. Why? Because in HashMap or in HashSet, the order of insertion is not maintained. So let's see the next idea. So here also, we will insert our frequency into our HashMap, but instead of iterating over the HashMap, we will now iterate over the original array. Because from the original array, it can tell us whether that element's frequency into the HashMap is 1 or not. So the idea is simple. We have to build the map where we will insert all elements and their frequency into a HashMap, and then we will iterate over the array and not over the HashMap, because HashMap doesn't guarantee order. And while iterating over the array, we will check in the HashMap whether that particular element is present in the HashMap has frequency 1 or not. And as soon as we get the element, we will return that element as the answer. So here is the code for the same. Here we ran a loop from for I is equal to 0 to n minus 1. We are checking whether the element is present in the HashMap or not. If it is present, we will update the frequency. If it is not present, we will insert the element into the HashMap with the value 1. And for finding out answer, we will simply iterate over the array. And for that, we ran a loop from for I is equal to 0 to n minus 1. And we are checking in the HashMap whether that element's frequency is 1 or not. As soon as we get the element's frequency as 1, we will simply return the element saying that this is the first occurring element, which is non-duplicate. Now, let's see the next problem of our day today, which is subarray with sum 0. So you have been given n elements and you have to check if there exists a subarray with sum is equal to 0. So if you have already remembered from our previous classes that how we are calculating the subarray, we used to take the help of prefix sum array, right? So we will try to use something similar like that. So as you already know that every single element is also a subarray of itself, right? So this question breaks down to two conditions. If any of the element is 0, that means that element is also a subarray, because single element are also considered as a subarray, right? So either element should be 0 or you have to insert that element into a hash set. So before doing anything like that, let's observe this. So for example, you have been given array 2, 2, 1, 3, 1, minus 3, 4, 3, 1, minus 2, minus 3, and 2. So what will be the prefix sum? This will be 2, right? 2 plus 2, 4, 4 plus 1, 5, 5 minus 3, 2, 2 plus 4, 6, 6 plus 3, 9, and similarly we will get all the elements. So if you closely observe, so we have got one subarray from here to here, starting from 2 to minus 3, which give us the subarray sum as 0, right? And if you have closely looked over the prefix array, in the prefix array, how we will come to know whether any subarray is 0 or not? If we found any repeating element. So now we will take the help of this prefix sum array and we will keep all the elements of the prefix sum inside the hash set, because hash set will never contain any duplicate element. So this is just for the observation that how using prefix sum array you are able to know that whenever any subarray is contributing 0, we are getting repeating element in the prefix sum array. Since we already know from our previous classes that sum of I to j can be expressed as pf of j minus pf of I minus 1. So according to our question, pf of j minus pf of I minus 1 should be equal to 0, right? And when we are summing from 0 to j, that time prefix of j will be equal to 0. But in the real approach, since we have already understood that anytime whenever a subarray sum is giving 0, that time prefix sum will have repeated element. So we will not create prefix sum array here, because we have also learned that without creating prefix sum array, we can also do sliding window problems using carry forward technique, right? So we will approach via carry forward only, and then we will try to solve the same. So let's see the code for this. So we have taken a hash set and initially the sum is 0. So our loop will start from for I is equal to 0 to n minus 1, and in the carry forward, it will add the sum. So the sum is sum plus is equal to a of I. So if any time this sum is 0, that time we will return true, right? Because in our question it says that we can return true if any element is also 0, right? So if our sum is 0, that means in our prefix sum there must be any 0, right? Or there must be two elements cancelling out each other, right? So that time also it will tell. Or else if it doesn't happen like that, then if sum is not equal to 0, that time we will insert that sum into the hash set. So instead of creating prefix sum, we will create hash set. So if you try run for this example, so when you are at 2 in your hash set, 2 will get inserted, right? Next again 2, the sum will be 4, right? So 4 is not equal to 0, right? So this if will not work, it will insert the element in the hash set because 4 is not present in the hash set. Next it will come to 1. So what will be the current sum? Now it will be 5, right? It will check in the hash set whether 5 is present or not. Since this is not present, we will keep 5 into the hash set. Now the next element is minus 3. So our sum will become 5 minus 3, which is equal to 2, right? Again 2 is not equal to 0. So this condition will not work and it will try to insert into the hash set. But since we already know that in hash set, it will not allow duplicate element to get insert. So 2 will get skipped, right? This 2 will get skipped. Now again it will move to this element 4, right? So our current sum is 2. 2 plus 4 will become 6. 6 is present in the hash set? No. So we will insert inside this. And similarly, as we progress, we will keep inserting all the non-duplicate elements into the hash set. So if you closely observe in the hash set, if there are any subarray which is making the subarray sum as 0, then there will be at least one element less present in the hash set. So if you have seen in the prefix sum, so these are 10 elements. In the prefix sum, this will be 10 elements only. But since instead of keeping it in prefix sum, we are keeping the same in the hash set. So hash set will not contain the duplicate element. That means 2 will not be there. So now there will be 9 elements only. So at last, we can check if the hash set size is lesser than the length of the array. That means there is some subarray which has contributed to 0. So this is a LeetCode problem. The link I have mentioned in the description as well. So what is the time complexity? Since we are running one for loop only, that is from I is equal to 0 to n minus 1. So the time complexity is O of n. And we have taken hash set in the starting for this approach. So our space complexity is O of n. So there can be a follow-up question on the same. What if you are asked that you have to calculate max length of that subarray where sum is equal to 0? So in that case, you will simply change your hash set to HashMap. Why? Because to calculate max length, you have to have the value of that subarray as an index, right? Because only when you have the index of that subarray, then only you can calculate the same, right? So if you see, the code is similar. We have taken a sum variable and we have taken an answer variable. answer variable will give you the length of that subarray where the sum is equal to 0. So just we are repeating the same thing. We are taking a sum variable where we are adding up the elements value, which is like a carry forward. Here, if sum is becoming 0, that time this will directly give you the answer. Here it was just for checking the subarray, but in this case you will have to give the length. So when sum is equal to 0, that means that is a single element, right? Here we will have the answer as answer is equal to max of answer comma I plus 1. And since in this where we are calculating max length, instead of taking HashSet, we have taken HashMap here, because now we need to store the index also of that particular subarray. So here we are checking whether that HashMap contains the sum or not. This will give us that what is the maximum length of the subarray sum with sum equal to 0. So if the sum is already present, as we saw in the previous example, that 2 was already present in the array. So let's see this code with this example as a dry run. So we have a hash map here. We will come to this for loop from for I is equal to 0 to n minus 1. We will check what will be there in the sum. It will be 2, right? So it will check whether 2 is equal to 0 or not. This condition will not work. It will check in the hash map whether 2 is present or not. Since it is not present, we will simply insert 2 with this index, that where we got that thing. So we will get 2 colon 0 as the first element. Now we will move to this 2. Now our sum will contain 4. Again 4 is not equal to 0. So this condition will not work. Again it will check whether in hash map we have 4 or not. It will say 4 is not there. So we will keep the element in the hash map with its index, right? Using this condition. Again we will move to 1. Now our sum will be 5, right? Since 5 is not equal to 0, this condition will not work. Now it will check whether in hash map we have 5 or not. It will see that in hash map 5 is not present. So it will keep 5 with index 2, right? Again this I, when it will come to minus 3, the sum will now become 2, right? So since 2 is not equal to 0, again this condition will not work. Now it will check in the hash map whether it is present or not. It will see that we have already encountered 2. So what is the length of the I right now? 3, right? And what is the previous 2 which we got? It is at 0. So what is the max length? It will be answer comma 3 minus 0. So what was the previous answer? Answer was 0. So the max of this will give us the length of that subarray. So every time whenever a subarray sum is giving result as 0, that time that element will get repeated in the prefix sum, or it will not store the element in the hash map. And while traveling, we already know that where it got repeated. So we have that index since I is running over the array, and we have already saw where we got that number because we already stored the number with its particular index. So this is how we can calculate the max length subarray. Now let's see the extension of the above problem. So here we have to count total subarrays which is resulting in the sum is equal to k. So earlier sum was is equal to 0. So whatever we did for 0, we simply have to do for k. So let's understand the prefix map visualization. So here we will track the running sum by pf of j. So if current sum is pf of j and we want the piece equal to k, then to find that the remainder we left behind must be equal to pf of j minus k, right? And if we seen already this pf of j minus k before, that means that subarray is equal to k exists. So you can also visualize it by keeping k is equal to 0, which will take back to your previous problem, how you solved it. So from here, our observation will be sum I to j will be equal to pf of j minus pf of I minus 1, right? And our sum I to j should be equal to k. So our pf of j minus pf of I minus 1 will be equal to k now. And if we have to calculate the sum from 0 to j, that time our pf of j will be equal to k, right? So let's see that with this example. Suppose array is given 2, 3, 9, minus 4, 2, 4, 6, 2, 5. And the k is given as 11. If you try to calculate the prefix sum, so it will be 2. The next will be 2 plus 3, 5. Next will be 5 plus 9, 14. Next will be 14 minus 4, 10. Next will be 10 plus 2, 12. And next will be 12 plus 4, 16. But in this, in the hash set, you will keep the elements present in the prefix array. But while checking in the hash set, you will subtract the target element from the element present in the hash set, right? So if you do 2 minus 11, is 9 present in the hash set? If you do 5 minus 11, is minus 6 present in the hash set? No, right? If you do 14 minus 11, is 3 present in the hash set? No. But at last, when you come at 16, you will see 5 is present in the hash set, which means that we have got a subarray where the subarray sum is equal to the target element 11. So which is this one, right? So this is 9 minus 4, 5, 5 plus 2, 7, 7 plus 4, 11. So after taking the prefix sum or the carry forward, if we subtract 11 from it, we will get an element present in the hash set, right? Because here it was 5, right? And here, if you subtract 11, that means you will get 5 only. So let's see the code for the same. The code is similar to that. So we have taken a hash set and we have initialized the sum variable. Now we are running a loop from for I is equal to 0 to n minus 1. We are adding up some of the elements using carry forward, and in the previous case, in the case of 0, we are checking whether sum is equal to 0 or not. Here we will check if the sum is equal to k or not, and once we get that, we will return true, or else we will check either we can get the target element as a single element, which we are covering through this condition, or we have to check in the hash set whether that elements pair which we can get by subtracting k from the current sum is present in the hash set or not. So if the hash set contains sum minus k, we will return true, and if both this condition is not true, in that case we will insert the element in the hash set. So let's see that with the dry run. So we started from 2. In our current sum, 2 will be there, right? So what will be present in the hash set? Since 2 is not equal to k, this condition will not work, right? Now we will check in the hash set whether 2 minus k, which is 11, 2 minus 11 is present or not. It is not present, so this condition will also not work, and we will insert that element in the hash set as 2. Now we will iterate to the next element, which is 3. Now our sum will become 5, right? We will check 5 is equal to k or not. We will see this condition will not work. Now we will do 5 minus k, which is minus 6. Since minus 6 is also not present, we will simply insert that element into the hash set, which is 5. Again, we will check the next element 9. Now our sum will be equal to 14. Again, 14 is not equal to k, so this condition will not work. Now we will check whether that element is present in the hash set or not. So 14 minus 11 will be equal to 3. 3 is not present, so we will again insert the new sum, which will be now 14, right? Now we move to the next element, minus 4. Our sum will become 10. Right now, 10 is not equal to k. This condition will not work. Again, we will see if hash set is containing 10 minus 11 or not, which is minus 1. So this condition will also not work. Again, we will insert that element in the hash set. So now 10 will be inserted in the hash set. Now again, we will move to the next element 2. So our current sum will be 12 now, right? We will check whether 2 is equal to 11 or not. This condition will not work. Again, 12 minus 11, which is 1, is not present in the hash set. Again, this condition will not work. Again, we will insert the current sum, which is 12. After that, we will again come to the next element, which is 4. Now our sum will be equal to 16, right? Now we will check 16 is equal to 11 or not. This condition will not work. But this time in the hash set, we will get 16 minus 11, right, as 5. So the code will stop it here, and it will tell that the sum is equal to k is present. So this is also a LeetCode problem. The link I have mentioned in the description as well. So suppose in the same question, if you have to count all the subarrays with sum is equal to k, so the code is same only. So whenever you are getting sum is equal to k, instead of returning, you will do answer plus plus. You have to keep one answer variable, and also in this case, since we have to count the subarrays, we have to store it in the hash map, right? So just like the previous code, we were checking in the hash set, we will check in the hash map whether it contains sum minus k or not, and if it is containing, then we will simply keep the frequency, that how many times that number came into the hash map, and for that we are checking whether that sum is present in the hash map or not. If it is present, we will increase the frequency of that sum, and if it is not present, we will update that sum element into the hash map with 1. So in case of you used hash set when you have to check the existence only, and you used hash map when you have to count the total number of subarrays present, because every time this sum minus this target can tell whether that element is present or not. So let's close with the consultant's guide to hashing. So when to use a hash set and when to use a hash map. So you can use hash set when you have to check uniqueness, as we did in problem number 1, or you can use hash set when you have to just check for simple existence, which you did in problem 3 part 1. So the mantra would be, have I seen this exactly once? When this kind of feelings is there, that time you will use a hash set. Now let's understand when to use a hash map. When you have to use it for storing and retrieving frequencies like you did in problem 2, or if you want to count total overlapping occurrences like in last problems part 2, you will use the hash map. So whenever you have to count how many times I have seen this, you will use hash map, and whenever you have to just tell that have I seen this once or not, that time you will use hash set. Finally, you have mastered hash maps and its associated problems. Practice this implementation. In our next lecture, we will cover count sort and merge sort. If you found this video helpful, please hit that like button and subscribe to Techmine Guru. Till we meet again, keep coding, keep learning, and keep optimizing.